Welcome back to my YouTube channel. Today let us discuss about the concept of electromagnetic and its applications. Now, let me give the introduction of an electromagnetic waves. Electromagnetic waves definition, that is, the wave produced when an electric field comes in a contact with a magnetic field are called as an electromagnetic or EM waves. And they are composition of oscillating a magnet and electric field that can be studied using a Maxwell's equation. And electromagnetic waves can be a radio wave and microwave and television wave and more. The different types of arises from this difference in the wavelength and its frequency. Now let us discuss about how the electromagnetic waves are formed. An electromagnetic particle, that is a charged particle, give rise to an electrical field, and this electrical field applies a force on the charged particle, and this positive charge and get accelerated and towards the direction of an electric field, and constantly a negative charge get accelerated toward the opposite direction, where the positive is in towards a direction of electric field and the negative charge is opposite direction of an electric field, and the moving charge particle give rise to a magnetic field, and this magnetic field extract a force to other charge moving and particles. Now let me tell you about how the electromagnetic waves are formed. As the result, an accelerating charge particle give rise to an electromagnetic field. Therefore, you can say that the electromagnetic wave are magnet and electric field traveling via free space with a speed of light, that is c, as you see in the diagram. And when the charged particle oscillate around the equilibrium position, it is termed as accelerating particles, charged particles, and so if the frequency of an oscillation is f, then the electromagnetic wave it produces will also have a frequency that is f. Now, let me say about the electromagnetic wave and examples and their uses. Now, the electromagnetic spectrum includes several electromagnetic wave types. Here in detail about each one of them. Now, at the first, radio wave. The radio wave is the longest wavelength among all the electromagnetic wave, and they can be used for foot long or even up several miles in the length. And this wave find a application in the data transmission via radio and satellites and computer and radar. As you see in the diagrams, the magnetic field that is B and electric field that is E, as the waves are passing through that. The second one is microwave. The radio waves, these microwaves measured in centimeters, they are extensively used as they are penetrate smoke clouds and the light rain. The universe has an immense cosmic microwave ground radiations that scientists connect a big bang. And next one is, and third one is infrared waves. In between microwave and a visible light, the region of infrared waves that is often classified into a near and the far categories. And the near infrared waves lies closer to the visible light, and they find the application in TVs remote to switch on the one channel to another channel. And the far waves that they are visible light in the wavelength and give off a heat. And the fourth one is visible light. The light spectrum that the human eye can see is called as a visible light spectrum, and it covers a wavelength from 390 to 7 nanometer, and the lambda is wavelength. And next, the fifth one is ultraviolet waves. UV, that is UV rays. UV rays are the next shortest wavelength rays larger emitted from the sun, and the ozone layer protects the earth from a sun's harmful and ultraviolet rays, and often some insect the bumblebees can be ultraviolet ray, and the powerful spectrum use a UV rays and to see the stars. And now let me see about the propagation of an electromagnetic wave. Electromagnetic wave can be propagated from transmitted to the receiver in the following ways, and it is in ground waves, sky waves, and space waves. Ground waves, they can be propagated along with the surface of a ground, and the process called as a ground wave propagation. And sky wave, when the electromagnetic wave is propagated via sky, it is called as a skywave propagation. In this type of propagation, the wave that get reflected back to the earth from the isosphere, and the space waves, so that is electromagnetic waves that often are propagation from transmitted to the receiver antenna without any reflection or a refraction, then it is called as a space wave propagation. Tell about the applications of an electromagnetic wave. The following are the few applications of an electromagnetic wave. The electromagnetic wave radiation that can transmit energy in a vacuum or using no media at all. And the electromagnetic wave plays an important role, as you know that, and in our communication technologies. And the electromagnetic waves are used in radars, and UV rays are used to detect a forged banknotes, and real banknotes do not turn into a fluorescent under a UV light. And now let me tell you about the formation of an electromagnetic wave. When a charged particle produces on an electric field, and the produced electric field exact from the force of another particle, leading to a negative charged particles, negative and both positive and negative charge, when these charges are accelerated, the positive charge comes to the direction of an electric field, whereas a negative charge tends toward a magnetic field direction, that's in opposite direction. And here the electromagnetic waves are the combination of a magnet and an electric field, and are produced by an oscillating charged particles. These are the formations of an electromagnetic wave. Let me tell you about the electromagnetic wave equation. The electromagnetic wave equation describes the propagation of an electromagnetic wave and through a material medium or a vacuum. It is a second order partial differentiation equation, and it is a 3D form. Additionally, the intensity of electromagnetic wave are defined by a formula I equal to P by A, where the P is power and A is defined as an area of the electromagnetic wave.